Okay, this is problem number 91 from page 109, section 1.3 in the pre-calculus book, and we are asked to find each quotient. A quotient is typically a division problem. Write the answer in standard form a plus bi. So we have seen that we don't really have a division process for complex numbers. Instead, all we're really going to do is some kind of algebraic technique that allows us to change the form of this expression and put it into standard form. And here's a problem that's more like the ones we did in our notes. Let's say it was 8 divided by 2 minus I instead of the problem that we're given. So what we learned was the key to changing the form of this is to use the conjugate of the denominator. The conjugate would be 2 plus I. We know that magical things happen when we multiply conjugates. When we multiply the denominators using the FOIL process, we get 4. The inside is negative 2i. The outside is positive 2i. Those add to 0, or we like to say they cancel. And then the last is negative I squared. And on the top, we could distribute the 8. We get 16 plus 8i. And then we can simplify the denominator because we know that I squared is negative 1. So the denominator is really 4 minus negative 1, which is 5. Is it in standard form? Not quite yet, because we have to separate the parts. So to get standard form, we'll break it into two fractions. The first one being 16/5. That's the real part of standard form. And the second one is 8/5 I. That's the imaginary part. So how can we go through that process with the problem we were given in number 91? It's not too bad if we change how the denominator looks. What if we write it as 8 divided by 0 minus I? 0 is the real part, minus I is the imaginary part. That looks more like this one. So what's the conjugate of 0 minus I? 0 plus I. Could you do it without writing the 0? Absolutely. This is just giving us a way to model what we did last time and use the same process. Okay, so multiplying the numerators together, 8 times 0 plus 8 times I. And multiplying the denominators together, the first we have 0, the inside 0, the outside 0, and the last negative I squared. Since I squared is negative 1, we have the opposite of negative 1. And so we just have 8i because it's 8i divided by positive 1. Is that in standard form? Yes. The only thing we could do to make it look more like it's in standard form is if we wrote 0 plus 8i, then we have our real part and our imaginary part, but it's unnecessary to do that. Let's just leave that off and keep our answer as 8i.